In this assignment, you need to write Python code to simulate simple two-gene regulatory network dynamics with the different p sub xy and py values. In the first part, you should be able to generate p sub xy plot that shows the effect of increasing pxy or increased protein production. The protein X levels should be constant, 10 micromolar, and the initial Y1 protein, which is control protein, concentration should be 0 micromolar. You need to use p sub xy value 0.4 and p sub y value 0.9 to simulate X and Y1 protein dynamics. Then you define another protein, which is Y2, and its initial concentration should be 0 micromolar. Then you will increase pxy value from 0.4 to 0.8, while p sub y remains the same, which is 0.9, and show Y2 protein dynamics on the same plot. Your simulation result will show that only steady state level changes and response time remains the same. In the second part, you need to generate p sub y plot, which shows the effect of decreasing p sub y or increased protein degradation. The protein X levels will be constant, 10 micromolar, and the initial Y1 protein, which is control protein, concentration is 0 micromolar. And first you need to plot control protein dynamics, Y1 protein dynamics, using the parameter values 0.4 and 0.9 for p sub xy and p sub y. You will assume that the initial Y3 protein, which is target protein, concentration is 0 micromolar, and you should increase p sub y value from 0.9 to 0.2, while p sub xy remains the same, which is 0.4, and show Y3 protein dynamics on the same plot. You will find that both steady state level and response time change this time. Let me explain the solution code. So Y1 is control protein and Y2 is used for p sub xy plot and Y3 is used for p sub y plot. In the first part, we increase p sub xy, which means we increase protein production. The first equation here, first difference equation is for control. And the second equation shows when we change pxy from px1 to px2, we want to see what happens. And we'll see that only steady state level changes and the response time remains the same. In the second part, we decrease p sub y, which means there will be more protein degradation. The first equation is just control. In the second equation, we change p sub y value. So instead of having p sub y1, we have p sub y2. And by having that, we see both steady state level and response time change. As you can see here, we have pxy plot. This is control. And when you increase your pxy value, you see that this blue graph with increased steady state level. But the response time, which shows how fast the dynamics reaches steady state, does not change. In this case, this is our control. And if you decrease py, which means there is more degradation, we have this plot. You see that the steady state level decreased because we have more degradation. But at the same time, this graph reaches steady state much faster compared to this. So basically, protein degradation affects both steady state and response time, while protein production affects only steady state.